Alrighties, hello everyone. Welcome to your pre-lesson video today on negative exponents and rational exponents. So let's get straight into it. Alright, so with negative exponents, so here's the thing. Normally when you're answering questions, the final answer wants you to have all of your exponents as positive. And so this is how you make a negative exponent positive, essentially, as you can see right over here, right? What you will want to do is, if right now x to the power of -1 is technically over 1, in order to make this positive, you are going to flip it upside down. Can you see that? Right? So as you saw just now, x to the power of -1 was on top. Now x to the power of 1 is at the bottom. So in order to make a negative exponent become positive, you are just going to flip it upside down. All right. Now, if we look at the next example, this. We have 3 over b to the power of -3. Our b, right, has the negative exponent. And we want to write our exponent as positive. So we are going to flip this upside down, right? So if it's at the bottom, if this is at the bottom, we're now going to put it on top. So as you can see, this will then become 3b to the power of 3. The 3 stays where it is because it has a positive exponent, right? It's a 3 to the power of 1, positive. All right, so 3 stays there. B just joins it because if it's at the bottom, it'll have a negative exponent. When you bring it on top, it will have a positive exponent. All right. So, like I said, with negative exponents, you just want to flip it upside down. So let's look at this next question. We have 2y to the power of -5 over n to the power of -3. I already did the answer for you. So as you can see, y and n are the ones with the negative exponents. So they're going to be flipped upside down. So y is going to go to the bottom and n is going to go to the top. 2 stays where it is because it is, like the question before, 2 has a positive exponent of 1. So it stays on top. See that? It stays on top because it has a positive exponent. N goes on top because it has a power of -3. And y goes to the bottom because it has an exponent of -5. All right. So as you can see, that's why this would be the answer in terms of positive exponents. All right. It is not the coefficient that's going to change the signs. It's only the exponents that will change its signs to positive and negative when you turn it back and forth. All right. Not the coefficients, the exponents. All right. Now, to answer questions with numerical basis and you have a negative exponent, this is my tip. Whenever you have questions with a negative exponent and a numerical base especially, it is a lot less confusing if you make the negative exponent become positive first. All right? Like I said, number 1 rule tip when you have a negative exponent and you're solving questions, make the negative exponent become positive. So let's look at the first question. We have 4 to the power of -2 times 2, right? So we have this as a negative exponent. We are going to make that become positive now. So we're going to put it as, so to become positive, we need to flip this upside down, right? So now it will become 1 over 4 squared. See how the coefficient of 4 is still positive 1, right? Because when we flip it, the coefficient doesn't change, it's still the same. The only thing that changes is the sign for the exponent. So as you can see, -2, this becomes 2 now because we have flipped it upside down and made it positive. All right. So we have 1 over 4 squared times 2. Now this 2 nothing happens to it yet, just because it has a positive exponent. Okay. So now let's solve. So we have 1 over 16 right? Because 4 squared is 16 times 2. Now we have 1 over 16 times 2, which would give us 1 over 8. And that will be the answer. All right? So like I said, negative exponents make it become positive first. Let's look at this question. We have 4 over 2 to the power of negative 3. This is a negative exponent. Let's make it positive first. All right, so we're going to write 4 as it is because it has positive exponent. We're not going to do anything to it yet. Now to make 2 to the power of negative 3 positive, we're going to flip it upside down. So we're going to bring it to the top to then give us 2 to the power of 3. All right. From here, let's find out. We have 4 times 2 to the power of 3 is 8. 4 times 8 is going to give us 32. And that is the answer. All right. Now let's look at this. We have x to the power of negative 2 divided by 2 times 6 to the power of negative 2. Again, we want to leave the exponents that are positive where they are, and the ones that have a negative exponent, we want to make that positive by flipping it, right? We want to switch its positions. So in order to make the terms with the negative exponents become positive, I'm going to bring 6 to the top to give me 6 squared. Right? I'm going to leave 2 at the bottom here because it's a positive exponent. And then I'm going to bring x down to give me x squared, right? Because if it was at the top, it has a power of negative 2. So now if I bring it to the bottom, it is a positive exponent. All right, from here we are going to square as needed. So 6 squared is going to be 36 over, let's see, 2 times x squared is going to give us 2x squared. Now, if you look, ooh, we can actually simplify, right? Because 36 and 2 can be divided, right? So 36 divided by 2 is 18, and 2 divided by 2 is 1, all right? So then finally, this is going to give us 18 over x squared, and that'll be the answer, all right? It might get a little bit tricky and confusing with negative exponents, so if you have any questions, bring it to your deep dive lesson or shoot me an email. All right, now with multiplying and dividing with negative exponents, essentially it is the same thing that you would do with your positive exponents in the product rule, the quotient rule, and the power rule, except now you do have to take into consideration the negative sign. So let's take a look. We have h to the power of negative 6 times h to the power of 2. So because the terms are multiplying each other, that means the exponents would be adding, right? So we have h to the power of negative 6 plus 2, which would then give us h to the power of negative 4. Now I want my answer to be in terms of positive exponents. And right now I have a negative 4. So in order to make this positive, I am going to flip it upside down, right? To give me 1 over h to the power of 4, and that is going to be the answer. All right. Now let's look at the next one. We have p to the power of negative 3 divided by p to the power of negative 9. Same basis, which means the exponents in this case would subtract from each other because the terms are dividing each other, right? So to set it up, I have p to the power of negative 3 minus negative 9, right? And then if we look, because negative and negative will make it positive. So we're actually going to do p to the power of negative 3 plus 9, which will give me p to the power of 6. And that will be my answer. Okay. Now let's look at this. Same thing, product rule, right? Because the term is being powered by negative 3, we are going to do m to the power of 4 times, oops, do the other side. 4 times negative 3, which will give me m to the power of negative 12. That's a negative exponent, and so I want to make it positive, and to do that, I'm going to flip it upside down, right? So I'm going to get 1 over m to the power of 12, and that will be my answer. All right, so as you can see, when you're multiplying, dividing, and powering with negative exponents, it's pretty much the same thing with positive exponents in regards to like the product rule, the quotient rule, and the power rule, except now you do need to take into consideration the negative sign. All right. Now, the next thing that we have are rational exponents. So essentially, a rational exponent it's an exponent that is in the form of a fraction, right? And then operations using the rules are like normal, so like the product rule, the quotient rule, the power rule, same thing, except now we just have a fraction. That's all. All right. So let's look at this one. We have n to the power of 4. That's power to 3/2. All right. So that means because they're powering each other, I am gonna do 4 to the power of 4. N to the power of 4 times 3/2. All right. Now I know these can be simplified, right? Because the 4 and 2 can both be divided by 2. Then 2 times 3 will give me 6. So that means my answer is going to be n to the power of 6. That'll be it. Okay. Now let's look at this one. We have 27p to the power of 6. All of these are going to be powered by 5/3. I actually noticed, right? 27, and I have a 3 here. If you actually notice, right? 27 is the same as 3 to the power of 3. So I can actually rewrite it like this. So 3 to the power of 3 times p to the power of 6. All of these powered by 5/3. Now, if I were to break this up, I'll get 3 to the power of 3 times 5/3. All of these times p to the power of 6 times 5/3. As you can see that, right? Now we can, according to the power rule, we can simplify it. We will multiply the exponents. Simplify. This will give us 3 to the power of 5. This will give us p to the power of 10. I can actually find the value for 3 to the power of 5, which would give me 243 times p to the power of 10. So my final answer will be 243 p to the power of 10. All right. So again, you'll do it like normal for your power rule, quotient rule, and product rule, except now it's just a fraction. All right. So nothing too crazy. Now for numerical basis with rational exponents, here is how you would solve it. So it does take a little bit of practice, right? So I would suggest go find some practice exercises outside of our classes and do this. It's really, really handy. All right, so let's look. We have 36 to the power of half. We can actually find this. If you notice, 36 is a perfect square of 6, right? So let's rewrite it as 6 squared to the power of half, right? Which means I have 6 to the power of 2 times half. Simplify, 1. So 6 to the power of 1 is equal to 6. And that will be my answer. All right. Now let's look at the bottom. We have negative 125 to the power of 1/3. If I notice, right, because third, that not only the denominator of your rational exponent will give you a clue of how they will relate, right? Something to the power of 3 will give me negative 125. I know that number is going to be negative 5 to the power of 3. All right, negative 5 to the power of 3 will give me negative 125. So I'm going to rewrite it as that to the power of 1/3. Ooh, let's open the parentheses. So now I know it's going to be negative 5 to the power of 3 times 1/3. Simplify everything. It's going to give me negative 5 to the power of 1. Therefore, my final answer is going to be negative 5. And that's it. All right. Now, this is a little trickier, but it's really nothing too crazy again. Now, when you're writing radicals in exponential form, right, sometimes it goes back and forth. It is really helpful to notice because for some questions, especially when you get into exponential and logarithmic function, this will come in really handy. So essentially, what you just need to remember is that the number that's at the square root, or the root, like b here, so it's 4, right, here, will be at the bottom of a fraction of your rational exponent. right? So think of this being brought to the side here, all right? Or, yeah, so the bottom of the fraction is brought to the side of the root and becomes that number, okay? Now let's look. These ones we're just going to practice writing it in radical form. So we're going to have the root sign. So now I know, 3 is at the bottom of my fraction. So I'm going to bring it to the side. And that is going to give me root 3, or 3 root 7, 4. I'm just going to leave it as where it is to the power of 4, right? So this is how I would write it in radical form. Cube root 7 to the power of 4. That's it. You can actually also go ahead and solve it, but since the instruction just asks us to express the expression in radical form, I'm not going to go ahead and solve it. All right. Now let's look at this. Ooh, we have 5x to the power of negative 5 over 4. Yeah, that's actually a negative side. That's not very clear, but it is. All right. So because it is a negative exponent, first thing we want to do, we're going to make the exponent become positive, right? So we're going to flip this entire term upside down. So that's going to give us 1 over 5x to the power of 5 over 4. All right. And now from here, because I know that whatever number is at the bottom is going to go to the side of my root. All right. So that's now going to give us 1 over 4 root. I'm going to just do it 5x to the power of 5. All right, and that's how you would write, that's how you change forms from exponential form to radical form for your exponents. All right. Now on the other side, sometimes they want us to write the radical form into exponential form for your exponents, right? So in this case, we're just going to do the reverse. Now I know my 6 is going to be at the bottom of my fraction. If I don't have any number here, that means it's 1. Right, so that means if I were to rewrite this in exponential form, it's going to be 10 to the power of 1 over 6. Okay? Now if we look at the second question, we have 1 over square root 3k to the power of 5. I know that if I don't have any number here, it actually means 2. And I'm going to bring that over here. I know that's really small, but I'm going to write it big for you now. So it's going to look like 1 over 3k to the power of 5 over 2. All right, because square root, that means there's a 2 in front of the root. We're going to bring that and make it become our denominator. All right, so that means it will look like this. Or if you ever wonder how it looks like with a negative exponent, right, which normally it doesn't. Normally it wants it like this. For a negative exponent, obviously, to make it negative, we're going to flip the exponent. We're going to flip the number upside down to give it a negative exponent. So essentially, it's going to be 3k to the power of negative 5 over 2. And that'll be it. All right. If you have any questions about this, bring it to your deep dive lesson. Now, on to the last thing of the day, solving equations with rational exponents. So it is, like I say, it's really handy to be able to switch back and forth between radical form and exponential form for your exponents when you have a fraction. So let's actually look at this. So we have x to the power of 3 over 4 equals 8. Let's see, I'm actually going to simplify my 8 first. I know for a fact that 8 is the equivalent to 2 over 4. Oh, look at that. We have, 2 to the power of 3. All right. Now from here, I have 3 also on my x over here. So I'm going to multiply, I'm going to power both sides with the reciprocal of 3 over 4, which is 4 over 3. So it's going to look like this. So we have x to the power of 3 over 4 power to 4 over 3 equals to 2 to the power of 3 powered by 4 over 3. And because of our power rule, we are going to multiply the exponents. So I know these cross out each other to give me 1. This crosses out to give me 4, right? So that means I'm going to get x equals 2 to the power of 4. I can find out what 2 to the power of 4 is, which is x equals to 16. And that will be my answer. All right. Now, for the last question of the day, let's see. We have x to the power of 5 over 4 plus 36 equals 4. First thing I'm going to do is bring all the like terms together. So subtract 36 on both sides of the equation. Going to give me x to the power of 5 over 4 equals to negative 32. I know for a fact that this is going to give me x 5 over 4 equals to negative 2 to the power of 5. Like the question before, I'm going to multiply both sides with the reciprocal of 5 over 4. Right, so I'm now going to get this. I'm going to simplify the fractions. I know obviously these all cross out to give me 1. This crosses out to give me 4. So now I'm going to get x equals negative 2 to the power of 4. Solve that to give me 16. All right. Now the other method that you could also use is from here. Let me just write it out. We have x equals negative 32. I could just also, straight away put 5 over. I could just straight away multiply both of these numbers with the reciprocal of 5 over 4, right? So get x 5 over 4, 4 over 5. I know this is going to give me 1, so I have x equals to negative 32 to the power of 4 over 5, right? Now from here, because my exponent here is a fraction, I can put it into radical form, right? Now 5 is at the bottom, which means I'm going to bring it to the side as the number of my root. So I am going to get 5 root negative 32 to the power of 4, right? From here, I know 5 root negative 32 is going to give me negative 2 to the power of 4. And that negative 2 to the power of 4 is going to give me 16. And that'll be the answer. All right. So you have 2 methods of solving this question. Eventually, as you can see, they pretty much boil down to the same thing. So use whichever one makes it easier for you to use. All right. Alrighties, well, that is the end for your pre-lesson video today on negative and rational exponents. If you have any questions, as usual, bring it to your deep dive lesson or shoot me a message or email. Alright, thanks for tuning in. Have a good rest of your day.